Welcome. In this video, we're going to find the area between two curves. So looking at the picture here, we have the graph, and this one is called sine of x, the graph of sine of x. And here we have a line segment connecting this point here to this point here. So basically, sine of pi over 6 is 1/2. So this point here is pi over 6, 1/2. And this point here is going to be pi, comma, 0. So to find the area, of course, we need to find the function for this line segment. So the way we're gonna do it is by using algebra technique. So first we find the slope of the line. The slope is gonna be 0 minus 1/2 over pi minus pi over 6. And that's equal to, if you do the calculation, it's going to equal to 3, negative 3, 5 over pi. And the next step is to use slope intercept form, which is equal to y is equal to mx plus b. Since this is a line segment, I'm going to use this formula. So we plug in m, which is negative 3, 5 pi x plus b. All we're left is to find b. The way we do it is we plug in a point, either this one or this one, but I'm gonna pick this one because this one has a 0 on it, so it's easy. So what I do is I put 0 equal to negative 3, 5 pi times pi plus b. So that tells me that b is equal to 3, 5 over pi. 3 over 5, I'm sorry, because the pi cancel, so it's 3 over 5. So the final line is going to equal to negative 3, 5 pi plus 3 over 5. So this is our function that we needed to find for the line segment. So now we know that this here is equal to y equal to negative 3 over 5 pi x plus 3 over 5. Now we're going to use integrals. We can use sums or integrals, but we're going to use integrals to get the exact answer. Okay, so now, now that we have a line and sine, we can compute the area. This area on the blue, we can compute it as area is equal to, so we go from, the x goes from pi over 6 to pi. So we put pi over 6 on the bottom and then pi on top. So in this problem, we're gonna have a delta x. That means that we're gonna integrate with respect to x. So we're gonna have sine of x minus the line, which is negative 3 pi x. So when you minus, this becomes plus, and this becomes minus 3 over 5 dx. Okay, now we integrate. That becomes negative cos x minus I'm sorry, the x goes here, negative 3, 5 pi x. The x goes here, so we don't confuse it. And then, so that becomes minus, and then let's distribute already. So this becomes positive 3, 5 pi x x squared and then over 2. So that means that we multiply these times 2 and this becomes 10. Okay, 10 pi. Okay, so now minus 3 pi x, and then we go from pi over 6 to pi. Let's check it. Okay, so negative, the antiderivative of sine is negative cos, then x squared over 2, so when we multiply 2 times 5, that gives us 10, and then negative 3 over 5, this is a 1, so the antiderivative is x, so that's good. Let's check here. Negative 3 5 pi x plus 3 over 5, that's good. Okay, so now this gives me, and if we do this on the calculator, you plug in your pi over 6 to pi into here, you're gonna get 1.2115, and because this is area, we're gonna put square units. So this will be our final answer. So this little piece here is 1.2115 square units. So remember, when we are computing the area between two curves, you need, of course, you're gonna need the function representation, and then you do an integral. In this case, I chose dx. That means that each little rectangle is vertical. But because we have dx with respect to x. But let's say I wanted y, I will have to go horizontally, and this has to be dy. So I would choose dx when we have something on top of each other, but when you have from right to left, use dx. Dy, that would be easy. So thank you very much. That's all I wanted to teach you on this video.